We all rely on GPS, right? Like it's practically second nature here on Earth. But can you imagine using it on the moon? That's not science fiction anymore. We're going to deep dive into some exciting news. How Earth's GPS network just helped make history on the lunar surface. And get this, it might even change how we explore the entire solar system.
Yeah, you know what's remarkable is that this isn't just about like extending a familiar technology. It's about opening up a whole new level of precision and capability for lunar missions.
Let's break it down. So on March 3rd, 2025, the Lunar GNSS Receiver Experiment, or LuGRE for short, touched down on the moon aboard Firefly Aerospace's Blue Ghost lander.
Right.
This was a joint mission by NASA and the Italian Space Agency. And what LuGRE did next is seriously impressive.
Yeah, it successfully acquired and tracked signals from Earth's Global Navigation Satellite System, or GNSS, the network that powers our everyday GPS. And this is the first time ever that Earth-based GPS has been used on the moon.
It's almost unbelievable when you think about it. You know, those signals were meant for us here on Earth, and yet they're strong enough to reach and be utilized hundreds of thousands of miles away on the moon.
It's really a testament to the power of these signals and the incredible sensitivity of the receiver technology. But it wasn't easy. Think about how weak a cell phone signal gets when you're, in a remote area. Now imagine trying to pick up a signal that's traveled all the way from Earth to the moon.
So how do they pull it off? What makes LuGRE so special?
LuGRE had to overcome a few major hurdles. First, the signal strength is incredibly weak by the time it reaches the moon.
Yeah, of course, of course.
And second, the moon itself can block the signals, making it like trying to use, GPS in a canyon.
Yeah, I can see how that would be a problem. So what did they do?
Well, LuGRE uses a combination of cutting-edge technology. One key component is its phased array antenna. Now, this isn't your typical satellite dish. It's a flat panel composed of multiple smaller antennas that work together to create a highly directional beam. This allows it to precisely target and lock on to those faint GPS signals coming from Earth.
That's clever. So it's like having a super-powered antenna that can just cut through all that interference.
Exactly. But there's more. To boost those ultra-weak signals, LuGRE uses a specialized low-noise amplifier, or LNA.
Okay.
This LNA is designed to amplify the faint GPS signals while keeping the noise levels incredibly low, allowing for clear reception. It's like using, noise-canceling headphones, but for space signals.
So it's a combination of a super-focused antenna and a noise-canceling amplifier. What a combo.
And it doesn't stop there. This thing is designed to work not just on the lunar surface, but also during its entire journey from launch, through its trip to the moon, and even while orbiting the moon. Talk about multitasking.
Yeah, it's mind-boggling to think about all the engineering that went into making this happen. I bet they were on the edge of their seats, like waiting for that first signal. Do we know when exactly that historic moment occurred?
We do. On March 4th, at precisely 7:48 a.m. Italian time, the team received confirmation. LuGRE had locked on to its first Earth-based GPS signal. Imagine the sense of relief and accomplishment in that control room.
I bet there were cheers all around. But before we get into why this is such a game changer, I think it'd be helpful to get a visual. Can you describe what LuGRE actually looks like?
Picture this, a compact rectangular box, roughly the size of a large briefcase. Inside, you've got the brains of the operation, the highly sensitive GNSS receiver, the low noise amplifier we talked about, and all the processing power needed to make sense of those faint signals. On top sits the phased array antenna, a flat panel constantly scanning the sky for signals from home.
So it's not some giant clunky piece of equipment.
Not at all. It had to be lightweight and efficient to hitch a ride on the Blue Ghost lander. It's a testament to how far miniaturization and technology have come that something so compact can achieve something so groundbreaking.
It really puts into perspective the ingenuity of the team behind this mission. Okay, so we know how it works. But why is this such a big deal? What's the significance of getting Earth-based GPS to work on the moon?
Well, for starters, think about how much we rely on GPS here on Earth for navigation, timing, and even financial transactions. Now, imagine extending that capability to the moon.
Yeah, suddenly lunar rovers don't need to be controlled with a joystick from Earth.
Exactly. This could revolutionize how we explore the moon. We're talking about a whole new level of autonomy for lunar missions. Instead of relying on Earth-based tracking, which can be slow and limiting, lunar missions can use GPS to navigate with pinpoint accuracy in real time.
So no more waiting for instructions from mission control back on Earth. That's incredible. Are there other benefits beyond just making things easier?
This has the potential to be a major cost saver. Think about it. Instead of building and maintaining a separate lunar navigation infrastructure, which would be incredibly expensive, we can leverage the existing GPS network that's already up there and working.
So we're basically piggybacking on a system that's already in place. That's brilliant.
It's incredibly efficient, and it frees up resources for other aspects of lunar exploration. But the cost-saving aspect is just one piece of the puzzle. What's really exciting is how this opens up a whole new world of possibilities for what we can do on the moon. Think about the implications for building permanent lunar habitats, which is a key goal of NASA's Artemis program.
I'm starting to see the bigger picture here. This is about building a sustainable presence on the moon, not just making quick trips there and back. And precise navigation is crucial for that.
Precisely. Imagine trying to construct complex structures, land spacecraft with pinpoint accuracy, or even coordinate rovers and astronauts working together. It all requires reliable and precise navigation.
This feels like a turning point in lunar exploration. We're moving from exploration to establishing a true foothold on the moon, and all thanks to something we use every day here on Earth.
And it goes beyond just government-led missions. This technology could spark a whole new wave of commercial activity on the moon.
Wait, you're saying we could have companies specializing in lunar GPS services? That's fascinating. Tell me more.
Absolutely. Imagine companies offering navigation data for lunar rovers, guiding them across the surface with pinpoint accuracy, or think about precise landing services for commercial spacecraft, ensuring they touch down safely and exactly where they need to be. It opens up possibilities for mining operations, tourism, and even scientific research conducted by private companies.
Yeah, it's like the birth of a whole new industry. It's amazing to think that something we use every day on Earth could spark such a transformation on the moon. But I'm curious about the scientific side of things. What kind of data is LuGRE collecting, and what can we learn from it?
LuGRE is constantly gathering information about those GPS signals. It's measuring their strength, how long it takes them to travel from Earth, and any variations or disruptions they encounter along the way. This data is like a treasure trove for scientists.
What kind of treasures are we talking about?
Well, for one, it can help us understand how those signals are affected by the moon's environment. For example, we can study how the lunar ionosphere, a layer of charged particles surrounding the moon, interacts with the GPS signals. This could help us refine future lunar navigation systems and make them even more accurate.
So we're not just using the GPS data for navigation, we're also using it to learn more about the moon itself.
Exactly. And here's where it gets really interesting. By precisely measuring the time it takes for GPS signals to travel from different satellites to LuGRE's receiver on the moon, scientists can create incredibly detailed maps of the lunar surface.
More detailed than what we have now.
Significantly more detailed. Think about the topographic maps we use for hiking here on Earth. Now imagine a lunar map with a resolution so high that you could practically see individual boulders. That's the level of detail we're talking about.
Wow, that would be incredible for planning future missions. Wouldn't it imagine being able to choose landing sites with unprecedented precision, or even map out safe paths for lunar rovers?
It would completely transform how we plan and execute lunar missions. And that's just the tip of the iceberg. With this level of precision, scientists can start answering some fundamental questions about the moon.
Like what kind of questions? Give me an example.
Well, one mystery that has puzzled scientists for decades is the exact nature of the moon's interior. We know it has a core, a mantle, and a crust, but the details are still fuzzy with precise lunar positioning data. We can measure minute changes in the moon's surface caused by tidal forces from Earth and the sun.
Tidal forces, you mean like the tides in the ocean?
Similar concept. The gravitational pull from Earth and the sun causes the moon to stretch and flex slightly. Now, these changes are incredibly small, but with LuGRE's data, we can actually measure them. And by analyzing these tiny movements, scientists can get a much clearer picture of what's going on inside the moon.
So we're using GPS data to peer into the heart of the moon. It's fascinating. It really highlights how something that seems so simple, like tracking GPS signals, can lead to such profound scientific discoveries.
It's a testament to the interconnectedness of science and engineering. And here's something else to consider. LuGRE is paving the way for future missions that could use even more advanced navigation techniques.
Okay, like what? Tell me about these future missions. What's next for lunar navigation?
Well, one idea is to create a dedicated lunar GNSS network. Instead of relying solely on signals from Earth, we could have a constellation of satellites orbiting the moon, providing continuous and even more precise coverage.
A lunar GPS network? That sounds like something straight out of science fiction.
It might seem that way, but it's within the realm of possibility. Imagine having real-time, high-accuracy positioning data available anywhere on the lunar surface. That would be a game changer for exploration, scientific research, and even commercial activities.
It's mind-blowing to think about what we could achieve with that level of precision, but I have to ask, how would we even go about building such a network? Wouldn't it be incredibly expensive?
It would certainly be a significant undertaking. But remember, space exploration is often about pushing boundaries and finding innovative solutions, and there are several approaches we can take. One option is to leverage existing satellite constellations like the European Galileo system, which already has some satellites with lunar-capable receivers.
Yeah.
We could augment that system with additional satellites specifically designed for lunar coverage.
So instead of starting from scratch, we could build upon what we already have that's smart. Are there other options on the table?
Another promising avenue is the development of smaller, more cost-effective lunar navigation satellites. These could be deployed in larger numbers to create a more robust and resilient network. Think about the CubeSats that have become so popular in recent years. Miniature satellites packed with advanced technology. We could adapt that concept for lunar navigation.
It's amazing how far miniaturization and technology have come. It really feels like anything is possible. But as we're talking about building these sophisticated lunar networks, I can't help but wonder about the implications for Mars. We briefly touched on this earlier, but could this technology be used to guide missions on other planets?
That's the ultimate goal, isn't it? To extend the reach of our navigation capabilities beyond the moon and into the depths of the solar system. And while using Earth-based GPS for Mars missions is impractical due to the vast distances involved, the principles behind LuGRE's success could absolutely be applied to developing Martian navigation systems.
So what would a Martian GPS system look like? What are the challenges and potential solutions?
Well, the most obvious challenge is distance. Mars is much farther away from Earth than the moon, which means the signals would be significantly weaker and take much longer to travel. We're talking about signal travel times of several minutes compared to just over a second for the moon. That introduces a whole new set of complexities.
I see. So real-time navigation wouldn't be as straightforward as it is on the moon. What else would be different?
The Martian environment itself presents a unique set of challenges. Mars has a much thinner atmosphere than Earth, which means there's less atmospheric drag on satellites. That's good news for satellite longevity, but it also means we need more precise orbit determination to ensure accurate positioning.
So we need to be extra careful about where we place those Martian GPS satellites. What about the signals themselves? Would they be able to penetrate the Martian atmosphere effectively?
That's another factor to consider. Mars has a lot of dust in its atmosphere, which could potentially scatter or absorb the signals we might need to use different frequencies or more powerful transmitters to ensure reliable signal reception.
It sounds like designing a Martian GPS system would require some serious out-of-the-box thinking. Are there any promising ideas being explored?
One intriguing concept is to use a hybrid system that combines signals from Earth with a local Martian network. We could have a few larger, more powerful satellites orbiting Mars that receive signals from Earth and then retransmit them to smaller receivers on the surface. This would reduce the signal travel time and improve accuracy.
That's a clever way to leverage existing infrastructure while adapting to the unique challenges of Mars. Are there other possibilities being considered?
Another approach is to develop completely autonomous navigation systems for Mars missions. This would involve using onboard sensors like cameras and laser altimeters to create detailed maps of the Martian terrain and then use those maps for navigation.
So a bit like self-driving cars, but for Mars rovers.
Exactly. Imagine a rover that can navigate complex Martian landscapes without constant input from Earth. That would open up a whole new world of exploration possibilities.
It's incredible to think about the potential of these technologies. But as we're talking about pushing the boundaries of exploration, I can't help but wonder about the bigger picture. What does all of this mean for humanity's future in space? What are the long-term implications of developing these sophisticated navigation systems?
Well, I think it's safe to say that we're entering a new era of space exploration, one that will be driven by precision autonomy and accessibility. As we refine these technologies, we'll be able to explore the solar system in ways that were once unimaginable.
It's an exciting thought, and I'm eager to see what the future holds. But before we get too far ahead of ourselves, I think it's time to bring it back down to Earth, so to speak. What does LuGRE's success mean for the average person here on Earth? How does it impact our lives?
It might seem like a distant achievement, something that only scientists and engineers should care about. But the reality is that space exploration has always driven innovation and technological advancements that have benefited us all.
Give me an example. How does something like LuGRE trickle down to benefit our everyday lives?
Well, the technology behind those highly sensitive GPS receivers, those noise-canceling amplifiers, those innovations will likely find their way into other fields. We might see improvements in our cell phone reception, more accurate GPS for our cars, or even advancements in medical imaging technology.
So the ripple effects of space exploration can be felt in unexpected places. It's not just about sending rockets into space. It's about pushing the boundaries of what's possible and then bringing those advancements back down to Earth.
Exactly. And beyond the tangible benefits, there's also the inspiration factor, seeing humanity achieve something as remarkable as using Earth-based GPS on the moon. It ignites our imaginations and reminds us that anything is possible if we set our minds to it. It's a reminder of the incredible ingenuity and resilience of the human spirit.
It's true, it's easy to get bogged down in the day-to-day challenges of life. But then something like this comes along and reminds us of the vastness of space, the potential for discovery, and the power of human collaboration. It rekindles that sense of wonder that is so essential to who we are.
And as we wrap up our discussion on LuGRE and the future of lunar navigation, I think it's important to acknowledge that this is just the beginning. We're on the cusp of a new era of space exploration, one that will be shaped by innovation, collaboration, and a relentless pursuit of knowledge.
It's an exciting time to be alive, and I'm grateful that we have shows like this to help us navigate the complexities of these groundbreaking achievements and explore the profound implications they hold for humanity's future.
Yeah, it's mind-blowing to consider like how far we've come in such a short time. Just a few decades ago, the idea of using Earth's GPS on the moon would have seemed, like science fiction. And now here we are talking about building lunar GPS networks and navigating rovers on Mars. It makes you wonder what the next few decades will bring. It really does. And that brings us to our final thought-provoking question for you, our listener. We've explored the practical applications of lunar GPS, navigation, exploration, scientific research, commercial opportunities. But what about the bigger picture? How might this technology change our understanding of our place in the cosmos? What other exciting possibilities might it unlock as we, venture further into the unknown?
That's a question worth pondering. As we push the boundaries of exploration and develop these incredible technologies, it's essential to step back and consider, the philosophical and existential implications. What does it mean to extend humanity's reach across the solar system? What new perspectives will we gain as we navigate the vastness of space with, increasing precision and autonomy?
Those are questions that will likely occupy philosophers, scientists, and explorers for generations to come. And while we don't have all the answers, one thing is certain. LuGRE's success is a testament to the power of human curiosity, ingenuity, and collaboration. It's a reminder that we are capable of achieving extraordinary things when we set our minds to it.
And as we conclude our deep dive into the world of lunar GPS, I think that's the key takeaway. LuGRE isn't just about navigation or technology. It's about the spirit of exploration that, drives us to push beyond the limits of what we know and to reach for the stars.
So keep looking up, keep questioning, and keep exploring. The universe is full of wonders waiting to be discovered, and with each step forward, we expand our understanding of ourselves and our place in the grand tapestry of existence.
Thanks for joining us on this incredible journey. Until next time, keep exploring the cosmos.